Hello everyone and welcome to Singularity One-on-One. Singularity One-on-One is a podcast feature of Singularity weblog where you can go and listen to it or download it in full. As you may already know, my name is Nicola, aka Socrates, and as always, I will be the man with the questions. Today, I am very privileged to have Spencer Greenberg as my guest on the show. Spencer is the Chief Executive Officer of Rebellion Research, the quantitative hedge fund that he co-founded in 2005 at the age of 22. So, hi Spencer, and welcome to Singularity One-on-One.
Hi, how are you?
Fantastic. I am very happy to have you here today. Let's jump right into the biggest reason here and not keep our listeners and viewers on their toes. Tell us, Spencer, what is so special about your hedge fund?
Well, Rebellion is unique because what we do is we take artificial intelligence and we apply it to stock market investing. In particular, we use a type of artificial intelligence that's known as machine learning.
That's very interesting. So let's go step by step here. First of all, you were 22 when you started the fund. How many years ago was that?
Well, we co-founded the company in about 2005, and we began trading in January 2007.
I see. So you've been around for about 4 years now. And in your experience, how is investing directed by artificial intelligence different than normal kind of investing?
Well, one thing about systems that are driven by artificial intelligence is that the systems can actually learn and change over time on their own.
Very interesting. And I know that due to some SEC regulations, you can only reply in a limited way to some of my questions. But can you elaborate a little bit more about the generalities, if not the specifics, about your fund?
Sure. So the basic principle is that we apply, as I mentioned, something known as machine learning. Mm-hmm. So that's a type of artificial intelligence that's getting computer software to learn automatically from data and then be able to make predictions from that data. And we apply that to over a decade of financial information. Basically, we have our learning algorithm analyze information about companies and then predict which companies are going to perform well and then actually trade based on that.
Okay, so let me take you here step by step. First of all, what is artificial intelligence in the investment sense, and you've mentioned the term machine learning. Perhaps you should make the distinction between machine learning and artificial intelligence for the benefit of our audience here.
Sure. So artificial intelligence is basically the study of how do you get intelligent behavior from a computer program. So that could be anything from playing chess to translating between different languages, or maybe face recognition tasks where you want to identify a face in a photograph. But machine learning is more specific than that. It's about getting a computer to learn automatically. So we can draw a sort of distinction between what you might call like classic AI and machine learning. Whereas in classic AI or an expert system, you would have someone with expertise in a task come up with a complex set of rules to get a computer to have intelligent behavior. Like, for example, you program in a computer heuristics about how to play chess, and you give the computer chess search algorithms, and you could achieve intelligent behavior through that methodology. And that contrasts with the machine learning approach, which is that you have the computer analyze a very large data set, learn from that on its own, and then be able to do whatever the task is based on what it has learned, rather than what an expert has programmed it with. So that shows a sort of a distinction between an expert system, which is a type of AI, and a machine learning AI.
You just mentioned a very large database system, but before that you said that you feed about a decade's worth of data into your system before the system comes up with its market transaction suggestions. Is a decade worth of data sufficient, and how does it compare to somebody like, for example, Charlie Munger or Warren Buffett kind of investor who have like 50 or 60 years worth of experience?
Well, there's this trade-off that occurs. If you use lots and lots of data, the data becomes less relevant. For example, it's not clear that what happened in the markets 25 years ago really pertains that much to the markets today. On the other hand, you could use less data and have it be more relevant. So there's a fundamental trade-off. We use actually over a decade, but we don't use 25 years of data. So there's a balance to be struck.
I understand. And again, my next question pertains to your computer named Star. Just feel free to share with us however much you think it is possible in terms of what does the name stand for, how smart it is, and how is it different and or similar to, for example, Watson? Sure.
So Star is the nickname for our main trading strategy, our artificial intelligence-based trading strategy. It's based on machine learning, as I mentioned. So it differs from Watson, which was IBM's basically program that plays Jeopardy, in that it's not trying to understand human language. So Watson was really designed from the ground up to play Jeopardy, and in particular, that involves solving really difficult language parsing tasks, trying to understand what someone's actually referring to when they use different words. Our system is really about analyzing data that has to do with the stock market. So it's a fundamentally different task. Both of them fall under what you would call narrow AI, which is AI that's designed to solve really a particular problem. So Watson, they're trying to expand it to get it to do some other tasks, but those other tasks are still related to parsing sentences in order to try to map words to concepts. So it's still quite related, even though it's not Jeopardy. What makes them similar is that they both are using machine learning. They're both based on having a learning algorithm analyze large data set and learn from that data set.
So presumably, another 4 years down the road, your system would be even smarter than today.
Well, the hope is that our system continues to learn so that every day it knows a little bit more than it did the day before.
And would you say that kind of a learning, is it linear or is it exponential?
I would not say that kind of learning is exponential. It's more that it's learning. So in our case, it's learning more about the way the markets work or what factors impact a company's performance. I think when you start talking about exponential learning, we're talking about things like learning how to improve yourself. And then you can, once you've made those improvements yourself, you can then use those improvements to learn more about how to improve yourself. That could be an exponential process.
I see. And let me ask you this then. The limitations of Watson, as seen by Jeopardy, are usually not hard facts, but usually idioms, sort of a unique structures, linguistic structures that are usually learned only through experience and cannot be easily deduced or is there an equivalent of that in investing in the sense of the black swan factor, something that cannot be predicted based on the market data, a totally unique event? And is your machine better or worse equipped to handle events and occurrences like that than humans, in your opinion?
It's an interesting question. So when you talk about events that are unpredictable, the so-called black swan events, I mean, those are going to take everyone by surprise by definition, whether it's a machine or a human. And so I think that as far as I know, the best way one can deal with that is you try to design a system that's going to be robust to many different environments. That involves traditional portfolio management things such as don't use too much leverage in your system, don't rely too much on your risk model because your risk model might go haywire in a really crazy time period. Make sure that you stay diversified. Make sure that your bets that you're making are not too correlated with each other, or are unlikely to become highly correlated even in a strange environment. So you can think about all these different ways to try and make your system safer. And some of these things a computer does have an edge at in that you're able to sort of enforce in a very rigorous way many of these constraints, whereas when you have human investors, it can be hard for human to sort of understand maybe the correlations between 50 different assets so that it can be hard for them to get an intuitive grasp of that in order to do portfolio management. In some ways, it's easier to do it algorithmically.
But how about the human factors? I mean, let's face it, most of the decisions taken on the market today are still made by people. So you can invest based on strategies connected to the sort of economics behind a certain decision, or you can invest based on the emotional motivation that other actors who are also investing with you would make. Mm-hmm. So do you not think that a human investor would be better equipped to predict the emotional motivations of other investors, and therefore game the market better than a machine, which is entirely logical?
Well, it's interesting because what you're asking is whether a human can simultaneously understand the cognitive biases and errors of other people and not fall for them himself, which is a challenge. And I think that there are some people that can do that. In fact, if you look at value investors, one of the mantras is value investing is to buy when others are selling. Of course, that's just not always a good thing to do, but the basic idea is that when other people are afraid, they'll tend to make mistakes. They'll tend to, out of fear, sell things for bad prices or for prices that are bad for them, and then you may be able to actually profit off of that. Human investors do that. But at the same time, if these biases are systematic, if there are certain errors that humans make reliably, which I believe there are, a computer might be able to pick up on that or might be able to infer such a pattern from data.
And what would be the benchmarks do you have any kind of a Turing type of an investment test to measure your system's performance in terms of benchmarks as opposed to a human investor?
Well, what you tend to do with quantitative investment strategies is you simulate them in historical markets, get an idea of how this would have performed at different periods of time. Of course, if something would not have performed well in historical markets, you shouldn't really rely on it to perform well in future markets. Although, of course, even if it does perform well in historical markets, it's not a 100% guarantee it will perform well in the future.
I see. So what is the motivation and the ultimate goal behind your work? Is it to make money, or is it to create the smarter machine learning algorithms and smarter artificial intelligence eventually? Both of those?
Well, I mean, our firm as an entity is focused on trying to provide good investments for our clients, and that's what we set about to do. From my own standpoint, I'm really interested in intellectual challenges and trying to think hard about difficult problems, and in particular apply mathematics, apply machine learning to solving those problems. And I think that the stock markets are one such problem.
Fantastic. Let me move a little bit more into the questions related to your own self, because you have a very interesting background. So let me ask you, first of all, in your own words, who is Spencer Greenberg? Are you an investment manager, an entrepreneur, a mathematician, an AI researcher, a geek, a tea connoisseur?
I do work in investment management, so obviously that label applies to me. However, I guess I would think of myself, before thinking of myself as an investment manager, I would think of myself as a mathematician, because that says a lot more about the way I think about the world. But even more so than that, I view mathematics as just one form of very systematic thought, which relies primarily on deductive thinking. And I think that more generally than that, I'm interested in thinking properly, which implies not just using mathematics, but also using the scientific method, using induction effectively, so there are lots of techniques for figuring out how the world works, understanding the world, making predictions, and I'm interested in many of those.
Let me see if we can dig in a little deeper in that here about the limits of deduction and induction, the limit of mathematics and science in general. A certain kind of criticism stems from the argument that You see, if we are perfectly logical, then we would be nothing more but mere machines. I mean, philosophers and poets for thousands of years have extolled our emotional intelligence.
Mm-hmm.
So, do you think that? Okay, so let me ask you two questions here. First of all, is there any way that a computer system or machine learning algorithm can take into account such emotional intelligence? And two is, do you not think that if that's not possible, there is something lost in the world, in our ability to perceive and model it and react in it and predict and model the future?
I view our emotional systems in our brain as being, well, first of all, extremely useful. I mean, anxiety helps alert us to danger. Anger helps us prepare us to fight when we need to fight. I mean, our emotional systems are obviously incredibly useful to us, and we could not get by just with our analytic thinking. And I'm sure that there are cases of brain damage where people lose a lot of the emotional systems, and I would strongly suspect that they're highly dysfunctional people. So I mean, but I think when we talk about logic as being like sort of the end all of things, I mean, it's making a bit of a mistake, because ultimately you could create a machine that was, suppose perfectly logical, but unless you gave it preferences or values or desires, it wouldn't do anything. Logic is something that you can use to accomplish a goal, but you need to know what goal you're trying to accomplish. And logic can't tell you what goal to accomplish. That depends on what you value or what your preferences are. And so I view them almost as separate things. You've got logic as an incredibly useful set of tools, and then you've got preferences.
And in that sense, then, it seems that we have to have a way to input the values, or if you will, the ethics behind or underpinning that kind of a logical system, right?
Mm-hmm.
So is there a way that we can do that in machine learning or in artificial intelligence at all?
Well, in machine learning, you do specify a goal of the system, and the way that you generally do that is you give it an error function, a function that measures sort of how bad the mistakes it's made were, and that actually implies basically what it cares about maximizing, or what it cares about optimizing. But machine learning today is used for very specific tasks: face recognition, language translation, investing, things like that. So your error function would be related to the task at hand. If it's identifying faces, you might count it as an error whenever it misidentifies a face, for example. So when you're talking about more general intelligences that go beyond the narrow AI of today, it's a much more complex task. It's very hard to define a set of preferences or values that say matter to a human being or matter to all human beings.
Absolutely. So before we move on to the sort of technological singularity related questions of our interview, do you have a tip or a single advice for some of our viewers in terms of the best way to approach investing in a world of exponential technology?
Well, one thing to note, and I think this is sometimes sort of overlooked, is that exponentially growing technology, for example, in the number of transistors on a chip, is not the same as exponentially growing value. Going from 1 gigahertz to 2 gigahertz does not allow you to do that much more, relatively speaking. I mean, it's not the amount of value is not doubled to having that chip. You can still do most of the things that you want to do. Whereas if you had a much slower chip and you doubled the speed of that might actually be really valuable. It might let you do things you couldn't have done before. So I mean, I think I would differentiate between when you see certain technologies growing, you need to ask, well, how much extra value are we actually getting out of that? And that's an important question to ask. But I would also add that you don't, in terms of investing, you don't need to be leveraging technology to do a good job at investing. There's still people like Warren Buffett and other value investors who are able to basically use their knowledge of what value is and how to measure value, and use essentially the fact that sometimes the markets behave irrationally to make good investments and to profit. And they're not technologically sophisticated at all. But on the other side, the fact is that there are ways in which the world is changing dramatically. And so, for example, computers continue to get faster, algorithms continue to improve, machine learning algorithms continue to improve. And so we should expect that more and more tasks that currently humans have an advantage compared to machines are going to be eventually moved over to machines, and that the advantage of eventually the machines will basically have an advantage in many of these tasks. So that's something to think about when you're thinking about what investments to make.
Thank you very much for that tip, Spencer. Moving on to the technological singularity. So first of all, have you heard about Ray Kurzweil and his concept of the technological singularity?
Yes, I have.
And what's your take on it?
Well, I think that as far as we know about the laws of physics, there doesn't seem to be anything preventing, to our knowledge, the construction of a machine that has great intelligence. In particular, we can look and see that it seems to be the case that natural selection over a very long span of time produced human brains, which are intelligent things, and that there doesn't seem to be any fundamental reason why we couldn't reverse engineer the way that those work or implement them in computer code. For example, maybe even at a very unsophisticated level, just trying to simulate every single neuron in the brain on a computer, that doesn't seem impossible. It seems very, very difficult, but not impossible. And if it's not impossible, it means that it would be possible to construct a machine of great intelligence, perhaps greater than human intelligence.
So if you were to rate in terms of probability, how likely do you think it is that we are going to experience some kind of a technological singularity in the near future or in the far-off future?
Well, it's a very, very hard thing to estimate. I would be very hesitant to put any kind of probability on that. What I would say is that the human race faces many challenges, things like nuclear weapons, bioterrorism. There are many, many challenges as a race, as a species that we face. If we can survive all these challenges for long enough, I expect that one day we will be able to figure out enough about how the brain works, or enough about learning theory or intelligence theory in general, that we'll be able to build a really intelligent machine. But I have no idea how to estimate when that could happen, or whether that could happen before we succumb to other challenges.
Well, perhaps we can speculate then a little bit more about, say that this actually does happen. Do you think that the human species is likely to survive such an event?
Well, I think one thing to keep in mind is that when we talk about this question of giving a machine logic versus giving a machine preferences or values, the behavior of that machine is going to depend a great deal on what values or preferences you give it. And if you try to give it very naive ones, it can get you into trouble. If I say to you, would you please get me some spaghetti? You know that there are other things in the world that I value besides spaghetti. You know that that I'm not saying that you should be willing to literally shred the world in order to get spaghetti. But if you were to code naively into a extremely intelligent machine, as its only desire, get me spaghetti, it would stop at absolutely nothing to do that. And so the danger is not so much the danger of a machine being evil or a Terminator-like scenario. The danger is that we give it a bad set of preferences or values or desires that lead to unintended consequences. Or I suppose that it's built from the ground up with a set of preferences that are not the preferences reflected by most of humanity. Maybe only the preferences that a certain small group of people cares about.
So in that sense, how concerned are you that sort of the work and the algorithms that you're writing for your smart investment AI can be used eventually by other people for, not such beneficial purposes?
I'm really not concerned about that, because what we work in is narrow AI. And the task of taking narrow AI and turn it into general AI is an extraordinarily difficult one. They're really, when you design a machine to solve a specific task, it's very, very different than trying to design it to be generally intelligent.
I see. So let me see in that sense, have your ideas about narrow AI or general AI evolved or changed in any way possible since you started your hedge fund and started investing based on the advice from your artificial intelligence?
Well, my views on general artificial intelligence have changed, but not because of my work on the narrow AI so much as just learning about the topic. My thoughts about narrow AI have changed just because when you start actually trying to build machines to do specific tasks, you inevitably learn from your failures and your mistakes and about what works and what doesn't, and why it works and why it doesn't work, and computational difficulties and that sort of thing.
And perhaps now is the time, because we're approaching the end of our interview, to tell us a little bit more about your PhD in mathematics. What is your thesis focusing on, and so on?
So I'm working on two projects right now. One of them relates to measuring the complexity of machine learning. The complexity of machine learning algorithm, I suppose you could say. The idea is it's sort of like Occam's razor. I don't know if you're familiar with Occam's razor, but basically the idea that it's a statement that simpler explanations are better than more complex ones somehow. And it turns out there's sort of something analogous to Occam's razor in machine learning that you can actually prove mathematically, but you have to be very specific and precise about what you mean by simpler explanations and what you mean by better explanations. But then you can show that in a way simpler explanations or simpler models are better, all else being equal. That is, if they have the same predictive accuracy.
We're moving forward here to the last two questions of our interview, Spencer. First of all, can you tell our viewers and listeners where can they go and learn more about your fund in general and your other work also?
Well, there's a little bit about our company you can read on rebellionresearch.com. And in terms of my thoughts personally, I write about them at spencergreenberg.com, which is my website.
Fantastic. And do you have a single message that you would like for our viewers and listeners to take away from this interview today with you? What would that be if you have such a message?
Well, since your listeners are most likely interested in the singularity, I suppose my message would be that to solve really difficult challenges like building a machine greater intelligence than a human, or even just predicting when such a machine might be possible to build, or whether we can build it at all, these are really difficult thinking challenges, and they require really precise thinking that's free of logical fallacies, that's free of cognitive biases, because our human brains are capable of an enormous amount, but they also tend to misfire at times and produce fallacious reasoning. They produce biased thinking. And so what I would say, one of the most important messages that I have is to work on your own thinking abilities, to learn how to really hone your thinking. And I have sort of unconventional ways of thinking about this, but learn about the cognitive biases. Go read Wikipedia's list of cognitive biases. Learn about the logical fallacies. Read Wikipedia's list of logical fallacies. And I think that even just that can be very valuable as you start noticing more and more when your brain has these kind of misfires, and you can avoid some of these problems and actually become a better thinker, better capable of tackling really, really difficult questions.
Spencer Greenberg, thank you very much for being here with us today.
Thanks a lot.